Mr. Aaron, Mr. Ryan, how are you today?
Good.
Good, okay. So today we'll talk about prime numbers. So what's prime number? Can you tell me?
A number that can't be divided into any one except for one and itself. Yeah. That's one number one.
Okay, so can you give me the...
One is not a prime number.
Prime is not a prime... one is not a prime number. Can you give me the smallest prime number?
Two.
Write it down. Okay, so we are talking about a positive, nothing negative,
It
okay?
could go 1 and 2.
1 is not. This 2 is the smallest prime number. So 2
you
is the...
go in the one pound table.
Yeah, and Excel. Okay, so what number are even numbers? How many even numbers there are prime numbers?
1.
What is that?
2.
Yeah, that's a very special case. That's the only even number that is a prime number. All other even numbers are not, right? Remember that, okay. So, do you still remember how we're checking the prime numbers?
We are...
For example, like 10. Is that a prime number?
If it's... No, it's not a prime number.
Yes,
it could go in 5.
Or 2. As I say, it's an even number. It's not a prime number. Okay?
If it's an even number,
yeah.
If it's 2, return yes, and other even numbers, no.
Okay, okay. So, given a number n, how do we check if it's a prime number or not?
N is any number.
Any number. I mean, for example, like given a number, integer n, and how do we check if it's a prime number?
We check like that.
Should we
divide it by 2.
And divided by 3 and divided by 4.
4 divided by 5.
Okay, actually we don't need to check if it by the even number because 2. If it's even number, we just cross out, right?
Yeah, if it's 2.
Yeah, and then we start with 3. Yeah, if 3, it can be divided by 3. If no, we check the 5, right? We don't need to check the 4, right? Yeah, because it can be divided by 4, it can also be divided by 2, am I right?
Yeah.
Yeah, because it's in, we just check if it's it can be divided by 2, am I right? Yeah. Okay, so on which number the maximum we are going to check? Like if it's 100, what number range?
90. I think 97 is the biggest.
I know. I mean, what I mean is 100, and then which number the maximum I need to check if it can be divided by. I give you 3 answers. Okay. 99, 50, 10.
What do you mean?
So I need to check that like 3, it can be divided by 3, 5, as I said, 2, I need to check 2, but I don't need to check if it can be divided by 4, right? 7, 9, 11, up to 10, 50 or 99. Does it make sense? Yeah?
Yeah.
So which number? Pick one.
That could, no, I don't really know what you mean.
Okay, so for example, 100. Normally, if you want to find out if it's in 1 times table or 100 times table, it's always 2, right? Mm-hmm. Then there's nothing between 1 and 100 that can be divided by 100, right? Then it's a prime number, alright? Yeah? And we need to check if the number can be divided by 100 in between the 2 and between 1 and 100. Does it make sense? That's the algorithm to check, right? No, for example, like 97, you're saying 97 is the largest prime number under 100.
9 is not a prime number.
I know, but how do you know 97? Because we are trying to...
We started from the 100, then 99, then 98, then 97, then, yeah, you know.
Yeah, but look, suppose we don't know 97 is a prime number, right?
Okay, so then...
Then we need to check any numbers from 2. We need to check 2, 3, 4, 5, to see if these...
That's 8.
Yeah, to see if 97 can
You don't
divide...
need to check 4.
Yeah, I know. So the thing is, how many numbers can we need to check? Given this number is n, we need to...
Because it's the odd number you don't... It's definitely...
Yeah, okay.
The one is 96, which is...
Okay, so you still don't get my point, right? Do you? I'm saying that this is number 97, so we need to check if we don't know, right? We need to check the number 2, 3, 4, 5, okay, 6, 7, 8, 9, 10. Until 97, until 96, that's one solution, right? We check every number between 2 and n, right? to see if it can be divided, right? If it can be divided, it's not a prime number, right? Does it make sense?
Yeah.
Okay, so what I'm asking is if a number n, how many times do we need to check the factors?
And we don't need to check over half.
That's right, yeah, so certainly not this one, right? If 100, right? Yeah, because it's more than half, we don't need to check, right?
Yeah.
It cannot be divided. That's what I'm asking, okay? Okay, so you're saying this. 100, certainly not 99 because it's too much, right?
Yeah.
Right? 50, you say because over half it can't be divided, right? Alright?
Yeah. Half. Yeah.
Yeah, that's one good,
Yeah.
that's one solution. But how about I'm telling you it's 10. 10 is the square root of 100. Why is that? Because look, if you find a number 100, yeah? If you find the number 2, right?
Yeah.
This is A, right? Right? It must be a number which is 100 divided by A, which is 50, right?
Yeah.
If it is 5, this is A. There must be 100 divided by A, which is 20. Does it make sense? So you always come with pair if it can be divided, right? Alright?
Yeah.
4, okay, what's the other pair?
25.
Yes, you see? So you always come with pair until 10, right? Because everything up to, look, 10 times 10 equals 100, right? And then you go to the next, which is 20. 20, we know, because when we go to 20, we know already in the 5, right? Yeah? Does it make sense? Yeah?
Yeah.
Two numbers times together equals 100. 10 and 10, right? If you increase one number, the other one needs to be lower down, right? If 10 goes to 20, and the other 10 needs to go to the what? 5. Alright?
Yeah.
If this 10 goes to 25, and this 10 needs to go be
So this one needs to, if this one doubles, this one
half, yeah?
Yeah.
So that's what I'm saying, it's always come in half. So it means we just need to check the number up to square root of n. Right? So which one is faster? Which one is faster? You're saying half, right? I'm saying square root. So which one is faster? Obviously, which one? Pick one.
this one.
Yeah, of course, 100. This is 50. This is 10. I just need to check 10 times. You need to check 50 times. Who is the winner? Daddy. Yeah? Okay, so I'm not going to write this. Okay.
Me. I'm the winner.
So that's the time complexity of checking that is what?
Me. N square. No.
Yeah?
And.
Okay, let's do
And. Yeah, you
Square
know
root.
that thingy.
is prime. I don't know what that thing is. And what's missing?
Column.
If n small equal than 1, we know it's what? Return what?
False.
Yeah, false.
If
If n is 2, return what? That 2 is a special case there. Yeah?
True.
2, come on, 2 is a special prime number you just said, remember? Yeah? If n can be divided by 2, return what?
False.
Yeah,
False.
because it's even numbers, right?
And
Even
it
numbers.
can be divided.
Yeah, because we just have this special case for 2, and all other even numbers we return 4 because they obviously 100, 200, 104 are not prime numbers. And now we just need to check I equals 3, right? Yeah. Why I times I smaller or equal n, right? Because look, why is this one? Look, why I times I smaller than equal n, right? I just said two numbers times it together. 10 times 10 smaller than 100, right? Alright? Yeah? Then what do? If n can be divided by I equals 0, return what? Return what?
False.
False, yes.
Yeah.
Okay, so now here, I plus equal what? 1 or 2? Now I'm 3. Okay, after checking 3, what's the next number to check?
5.
5, yeah, because we don't want to check 4 already. We want to skip it. Even number we already check here, right? Yeah? So I plus equals to, and return what? If we go through this, return what? This is return false. After the invalid cases, what should we return? What should we return?
We should
Return what? After the checks. Okay, look. These are, we're looking now for the factors that can be divided by I, yeah? Can be divided by 3, can be divided by 7. If I can't find anything that can be divided by n, what does it mean?
True.
Yeah, return true is a prime number, okay? Does it make sense? This is the algorithm to check if the number is a prime number or not, right?
If t equals 2.
Does it make sense? If and look, if n is 2, return true. If n is 3, come here. Right? If n is 3, 3 times 3 is smaller than 3, it won't go in there, right? Return true. If 100, 97, let's say, 97. Smaller than equal 1, return false, no. 2, no. Even number, no. I equals 3. 3 times 3, 9, smaller than 97, yes. If 97 can divide it by 3, no. And then let's check the next number, 5. 5 times 5 smaller than 97, yes. And divided by 5, no. And next number, 7. 7 times 7 smaller than 97, no. The next one is 9 times 9 smaller than 97, yes. And 97 can be divided by 7, no. And next number, 11. Then 11 times 11 is bigger than 97, then we return true. We don't come in here. Does it make sense? Yeah? Okay. How about if I tell you a number? Okay, look.
What?
If I tell you a number 3 and you need to give me the list of prime numbers that are no bigger than 3. So 3, you give me a list. 2 and 3, right? And 10. What are the prime numbers after 10? Under 10.
2, 3, 5, 7.
Well done, that's it. Okay, so yeah, given this function, and we want to know the prime number. We want to collect the prime numbers in a list under that. So what's your approach?
Okay.
So what's your approach? We just need to, well, how can we do it? How can we do it?
Okay, so,
Right. So what's your approach? It's
We'll
one
solve
step
it.
forward. Yeah, we'll solve it. So basically we check all the numbers up to n, right? To check each one if it's a prime number, and we'll push it into the list. Yeah. So it'll be simple like that. Look, answer equals empty list. Yeah. Then for I in range, that's okay. I'm just doing this. Start with 2, okay? Yeah. And up to n plus 1, right? Because we want to check the n. N plus 1 means the last number is n, right? Then we say if it's prime I, then what? Answer dot append what? Append what? I. And return what?
Return.
What?
Answer.
Yeah. Okay. So all you can do in one line. Look, you can say return. Alright. Return bracket. Yeah.
I thought you were going to
X.
return true.
X, look, for X in range, you can do it in one line. Range, start with 2, n plus 1, and then do what? If it's prime. Yeah, this is a fancy way of writing it. It's the same. X.
I'm not fancy.
Look, does it make sense? Return
This
it.
one.
Yeah, this is the traditional way though.
This one.
Yeah, this is a traditional way of doing it, right? But we can write it. Return, I want to return what? A bracket, which is the list. What kind of list? Return X, contain S. What's S? X is in the range of 2 to n plus 1. And additional condition is if its prime is X, yeah? Does it make sense?
Yeah.
This is called list comprehension in Python. Can we do better? All of this,
Maybe we can.
look, Eric. This is
Maybe
ON,
we
right?
can't.
Yeah, Eric? This is ON loop. And combining with this O square n. So the overall complexity is ON square n, right? Does it make sense? Right? Look, iterate n times. And for each one, you need to iterate square root n, right? So all together, combine, right? Because this thing is inside the loop, right? Does it make sense?
Yeah.
If you want to complete this task, you need to do this n times. For each n time, you need to do this square root n times. So times together, multiply together is O(n) squared. Can we do better?
Maybe we can.
Maybe we can't. Can we do better, Eric?
Yes, of course.
Okay, so what's your approach? What's your approach?
I don't know.
You don't know. Okay, that's fine. That's fine. So we're talking about another new problem, which is more efficient in this case. It's called SIEVE, Sieve something, but you can just call it Sieve algorithm.
Sieve.
This is actually
Sieve something.
Okay, so yeah. Okay, look. So how can we generate the numbers more efficiently, right? Because for previously we need to check each number, right? There's no way to skip,
okay,
right?
So you skip.
What?
Okay, so you put 2 in it first, yeah?
Yeah.
And you check everyone, not the other even numbers, and not over half. And over half, I mean that's the thingy, and not the other even numbers.
You are a little bit close, but not too quite. Okay.
Why?
Okay, so I'm telling you. Look. So look. Let's say I want to generate all the numbers under 20, prime numbers.
Okay, that's
Yeah,
will be
okay.
easy, Peter. Let me
Alright.
see.
So we know. We know. 1 is not, right? We start with 2, okay? 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, these are the candidacy of the numbers. Okay, we want to find out the prime numbers. We want to generate all the prime numbers under 20, right? Yeah. So we start with 2. 2 is the prime number, right?
Yeah, of course.
So we set everything to true. We just assume every number is the prime number, okay? Okay, for now.
So first, you cross out all of the even numbers except from 2.
Well done. Let's. Wow. How do you know? Yeah, that's what I'm saying. Yeah, 2. I cross every multiple of 2. So which 2 is 4 is not, 6 is not. Every 2, yeah. Okay. Okay. Now I cross out it. Okay. Now I move to the next prime number, 3, and I cross out every possibility of 3 multiple of 3. 6, 9, 12, already crossed out. 15, 18, okay, that's it. And I go to next prime number, which is 5, and I cross out every multiple of 5.
None, they're all crossed out.
10, 15, cross out. And the next prime number is 11, I cross out the multiple, it's
7.
gone. Okay, 7, and 7, 14, yeah, and then 11, it's out of, yeah? So these, all the rest. You see?
All of those are prime.
You see? This is efficient, right? Why this will work, right? Because every time I have prime number, it's multiple, it's not prime number, right? Yeah? Alright? And the remaining, if we keep doing this, the remaining is the are the prime numbers, right?
So don't you need to go over half because you know.
Yeah.
Over,
Yeah, because we don't need to go to the half, right? What's the complexity of this?
Something.
This
It's
is
better
n
than
numbers.
last time. It's better than last time.
Yeah, of course, this complexity is O(n), right? Because we need to possibly cross out n numbers, yeah? Alright? But not less than that, yeah?
Yeah.
Okay, let's do this, okay? This is far better. When we want to know list of prime numbers under a range, right? Because we can keep generating it, right? Does it make sense? Do you understand, right? Yeah? It's easy, yeah? It's fun, yeah?
It's easy peasy lemon peepee.
Okay, that's it. Let's do this. Define, let's do it. Define primes, okay? Primes, let's do n column, yeah? Okay, now, look, Eric. Let's say the is prime, let's do this, is prime array, right? Equals, at the beginning, 4, 0 and 1. 0 and 1 are not prime numbers, so I times 2, right? And plus all others, let's say it's all prime numbers. 2 times n minus 1, right? So all together it will be n plus 1 numbers. Am I right? Yeah? 0 to n, it will be n plus 1 number. Now what should we do? we should cross out the numbers, right? We should start crossing all the numbers. Let's say I will be equals to 2, right? Yeah? Alright?
Mm.
Okay, so now let's say while I times 2, right? Because y times 2, I times 2 smaller than n, right? Smaller or equal than n, right? Because when it's passing the half, there's no point to check the multiple, right? Yeah? As you say, you don't need yi. Like look, if it's prime, if it's a prime, right? If it's a prime, if currently it's a prime number, column, yeah? And then we need to mark multiple of it. So j will be I plus I, right?
Mm.
And then while j is smaller or equal n, and then we mark it as the false, right? Is prime j will be false, right? Alright, Eric? And then j plus equals I. Alright? Okay.
Yeah.
And if it's not a prime number, what should we do? We just simply I plus equals 1, right? Okay?
Yeah.
And after this, if its prime is true, then we know it's a prime number. So we can do this. Return bracket like the syntax. X for x in range.
Is that fancy, right?
Yeah, range n plus 1, right?
Mm.
If or you can put start with 2. We know that 0 and 1 is not, right? If what is prime? Is prime bracket x, right? We want to check, right? Yeah, does it make sense? Look, we start with number 2, right, Eric? We start with number 2. When I is less than half, right? We want to find out if it's a prime number, we start with 2 plus 2, which is 4. And we cross out every number which is 2, right? So 4, 6, 8, right? Until it's j is bigger than n, right? And if it's not a prime number, it means that the number has been crossed. So we skip it. Next one we find next prime number and cross out the rest. Does it make sense?
Yeah.
Does it make sense? Okay. So I'm going to erase this one and erase this one. Just 2 here.
Are you kidding me?
Yes, of course, baby. I know you can do it.
I can't.
Why is come? Okay, so j equals I plus y.
I know the bottom one.
Okay, so
I
we
think
want to
it's
cross
something
down.
with J.
Yeah, of course. So j smaller than I, smaller than n. J is 4, for example. Yeah, add equal 1. We want to add a multiple equal 1. Yeah, add equal 1.
2.
2. Which one is 2?
I.
Yeah. Okay. And why we are doing this? Why j smaller than equal n? What should we do? We want to mark this prime to false, right? Cross out the numbers.
I know this is false.
Yeah, so how do we cross out the numbers? How do we cross the numbers? This is the array. It's prime array. It's the array which is true, false, and we want to cross out j in the array to false. So which array are we using? Where is the array? No, this is prime array. Come on.
Is prime.
Yeah, it's prime what? It's prime, and how do you reference the j number? Yeah, j bracket.
So use bracket.
Yeah. You see, it's easier to read, but when you actually write it, it seems harder, right? Am I right? Yeah. So practice makes perfect. Even you understand. If I erase it again, you will think about it. Yeah. Does it make sense?
Mm-hmm.
Does it make sense?
Any column or?
No, not column. Because every time you column, you start with the next standard with some space in before, right? Does it make sense? Yeah.
Yeah.
Okay. One more time. Okay. Okay. What's this?
I think it's for thingy and add.
J I equals what?
What?
Yeah, j equals what? Come on, I just erase it in front of you.
I?
Yeah. I plus what? I plus what? I is 2, then J, we start with what? We want to cross out the numbers starting from the next one. Which
What?
is 2. What's the number?
2.
Come on, I is 2. Right? I'm going to cross out the numbers 4, 6, 8. So what's 4? I plus
It's
what?
in the I times table.
Yeah, so I
plus 2. No, I.
not plus 2, I plus I, come on. It's a multiple
Plus
of.
I.
Yeah, or I times 2. That's okay. Does it make sense? Does it make sense now?
Yeah.
Okay. Okay. Is it? Do you really understand? Yeah. Okay.
If I say yes.
Okay. That's it for today.
Bye.
Bye.